Alright, so we're going to finish the last part of this section, which is called piecewise defined functions, how to evaluate and graph them. So here's an example. F of x is equal to, and it's going to be the x minus 1, I mean. So x minus 1. Okay, and that's if let's see, negative 4 is less than x, which is less than 2. And then the second one is negative 2x. And that's if 2 is less than x, which is less than or equal to 4. Right, so this is the actual piecewise function. We actually have two functions combined here, and these are our limitations of what x values we can use. So the first one that I'm going to do is the first one, x minus 1. So I'm going to write f of x equal to x minus 1, and then I'm going to make a table. Okay, and this is x, and this is f of x. And so I start at negative 4 and go all the way to 2. So that's negative 3, negative 2, negative 1, 0, 1, and 2. And so here are all my x values that I can put in. Alright, and so if I put negative 4 in, negative 4 minus 1 is negative 5. And negative 3 minus negative 1 is negative 4. So it's decreasing by 1. Negative 3, negative 2, negative 1, 0, and 1. Okay, and so now I can go ahead and graph that. So not a very straight line there this time, but there we go. And so let's do that again. Maybe make it easier to graph. So there, that's a little bit better. Okay. And so I'm going to graph these points. I'm just going to graph the first one and the last one because I see they're only increasing by 1. So there's negative 1, negative 2, negative 3, negative 4. And then it goes down to 1, 2, 3, 4, 5, negative 5. So if I line it up, I have a point here. And then we have 2, 2, 1. And I circled it because you notice the inequality, it doesn't have an equal sign. So this is open. This is open here. So if I do that, that would be 2, 1, 2, and then up 1. So here it is right there. And so if I connect those together, okay, then I have this line for all these values that are in my table. Now I'm going to go ahead and do the second one. F of x equal to negative 2x. Okay, and my limitation is between 2 and 4. So when I make a table, then I start at 2, and I go to 3 and to 4. So only 3 values I really need. So if I put 2 in for x, 2 times negative 2 is negative 4. 3 times negative 2 is negative 6. And 4 times negative 2 is negative 8. So I'll plot the first and last point. So I go to 2, I go down to 4. Okay, because this is negative 4. And then we'll continue this on. So it's negative 6, negative 7, there's 8, negative 8. And I have 2 more here because that's 4. So 4, negative 8, so something like that. And I connect that line. So here is a graphical view of what this function looks like. If I wanted to state all of the y values, right, then I could write it as a compound inequality. So my lowest number is at negative 7. I'm sorry, negative 8. So I would write negative 8, and since it's solid, it can be less than or equal to x. And then it doesn't get any higher than 1. So but it's not equal to 1. And so here is the y values from the lowest to the highest. So in case you wanted to see that, I just think sometimes it's nice to see that. But here is me showing how I numerically went about solving and graphing a piecewise function, and that's something you'll have to do as well. So that takes care of that.